All right, welcome to part 2, where we're gonna solve some polynomials. Oh yeah. Okay, so there are 3 main techniques to solve polynomials. The first one is factoring. The second one is the quadratic equation, which is my personal favorite. And the third is graphing, which can also be super useful, but it's a lot easier if you have a graphing calculator or some statistical program like R or Python to do the heavy lifting for you. I think also Wolfram and Alpha does it too. Anyway, graphing software, super useful for being able to graph polynomials instead of doing it by hand. Okay, so factoring. Let's look at an example of the form x squared plus 4x plus 4 equals 0. So anytime we're going to solve a polynomial, we have to understand what we're solving for. And just like if we have an equation x plus 1 equals 5, we want to figure out what value or values, plural, of x will make this equation true. And so in this case, we just want to get x by itself. And so we subtract 1 from both sides and say, well, when x is 4, this equation's true. Pretty straightforward, right? We do the exact same thing with polynomials, except in this case, we can't really start moving things to the other side because we have 2 different terms with x in it. So if we were to do x squared plus 4x equals negative 4 and then pull out an x, you get x plus 4. This would be a little weird because then you're like, wait, what do I do with this x? So that's why when we are solving polynomials, we typically want to have 0 on the right side of the equation, or on one side of the equation. Really doesn't matter. But we want 0 on this side of the equation, and here is why. When we have a number or a variable multiplied by 0, the answer is always 0. If I were to tell you I have 0 fruit, then you coming in and asking me if I have watermelon, I could be like, no, I said I have 0 fruit. It means I have 0 of any kind of fruit, whether it's banana or kiwi or watermelon or tomatoes, which are a fruit. 0 of anything is 0. So in that case, I can say x times 0 equals 0. And this could be more than just a single variable. It could be x plus 2 times 0 equals 0. This is still true, but in this case, instead of just a single number or a single variable, I have an expression that then equals 0, so that I know that this x plus 2 must equal 0. Or well, I guess in this case it doesn't have to equal 0, but I'll show you what I mean in a second. So, okay, to factor this, it really just comes down to knowing patterns, and because I've done this more times than I can count off the top of my head, I can tell you that it's x plus 2 times x plus 2 equals 0. Always check my work. In this case, since I have 2 things multiplied together that equals 0, I know that one or the other must equal 0. Because if this term equals 0, then 0 times this is 0. And likewise, if this term, or if this expression equals 0, then this term, it doesn't matter what is in this term, the whole equation will be true. It's a little silly to see it with 2 of the same number. So for example, if I had an x plus 3 here, then I would solve these 2 separately. Okay, but for now, let's just look at the x plus 2 scenario. So what I do to solve this polynomial is I say, okay, well, I'm going to set this equal to 0 and solve for x. So I have x plus 2 equals 0. We subtract 2 from both sides to get x equals minus 2. And then to double check that this solves the polynomial, you would plug it back in and make sure that you get 0 on the right side, or on both sides of the equation in this case. So that's factoring. I think factoring is helpful in that it helps us understand how and why we're solving polynomials, but there are very specific circumstances in which we can factor by hand. So if you don't have something that's nice and neat, it can be really hard, if not impossible, to do it by hand. That's where the quadratic formula comes into play. So at the end of the day, we do actually have to memorize the quadratic formula, but it is super useful, and I've used it more times than I can count. If you continue in math or in science, it will come up all the time, and eventually you'll just be so used to it that you won't even have to think about it. But when we're first learning it, we do have to memorize it. Fortunately, there are some tricks. When I was in high school, my algebra teacher taught us a version that goes along to the tune of row or row your boat. So I'll teach you that. But first, let's look at a generic form of a polynomial. And what I mean by that is a polynomial that can be generalized to really any polynomial of this type. So that's going to look like ax squared plus bx plus c. And we're going to assume that we have that 0 on the right-hand side of the equation. Quick PSA, if you don't have 0 on the right side of the equation, that's when you need to simplify to bring all the terms over onto the other side so that you get 0, and then you can use a quadratic formula. For the quadratic formula to be applicable, you do have to have your polynomial equal to 0. Okay, so that being said, we have 3 little mini variables in here, a, b, and c. These are actually not true variables. In this situation, they are stand-ins for constants, which are just numbers that don't change. But I don't want to pinpoint myself into one specific equation. I want to look at all polynomials of this type. Sometimes you might have c equals 0 or b equals 0 or something like that. But the quadratic equation will work for all of those examples. Okay, so now with all of that rambling, let's look at what the quadratic actually is. So I'm going to sing it to you in the row, row, row your boat format. All right, here we go. X equals minus b plus or minus square root b squared minus 4ac divided by 2a. So I can sing a lot faster than I can write, but hopefully that helped you. I'm all blurry, so I'm going to tap the screen. Hopefully that helps you. Sing it to yourself over and over and it'll get stuck in your head, which is good because then you can memorize it. Okay, so basically this maps the constants in front of our polynomial terms into an equation that works to solve whatever polynomial of this form we might have. Okay, and the last thing I'll mention before we do a quick example, hopefully it's quick, so remember how we were looking at like x plus 2 times x plus 3 equals 0? In this case, if we had a polynomial that we factored like this, you'll notice that x equals minus 2 and x equals minus 3 solve the equation. So there are 2 possible answers that are both equally valid. And that is actually baked in to the quadratic formula. Woohoo! So it makes our life way easier, assuming we do all the math right in this little equation. Basically what we would do, I'm making that plus sign real big, is we crunch the numbers, we simplify the terms in the square root, and then we add that to get our first root, and to get the second root, we would subtract it. Okay, so what does that actually look like? Let's do a simple example. So let's say I have a polynomial, 2x squared plus 3x plus 1 equals 0. Then my quadratic formula is going to look like this. X equals minus b plus or minus square root b squared minus 4ac divided by 2a. And we're going to simplify. So we have minus 3 plus or minus the square root. 3 squared is 9, minus 4 times 2 is 8, times 1, which is just 8, divided by 4. We're going to simplify a little bit more before we split it up. Plus or minus 1 divided by 4. And the square root of 1 is just 1, so I'm going to erase that. Boop. And now you can see that we have, we have our 2 roots that we can pull out like so. So x1 is minus 3 plus 1 divided by 4. x2 is minus 3 minus 1 divided by 4. And so to get our two roots, we just solve these little equations. Not so bad, right? Okay, so minus 3 plus 1 is minus 2 over 4, which is just negative 1/2. Minus 3 minus 1 is negative 4 over 4, which is negative 1. And my favorite part of this is that you can take your answers, minus 1 and minus 1/2, and plug it back in. So you should do both of those. This is my challenge to you. Double check my work, because to be honest, the first time I did this, I did it wrong. And it was only in checking my work that I caught it myself. So this is a really, really good habit to get into, whether it's on homework, a test, or just for funsies. So what you would do is you would plug these roots in for x. So for example, you would say 2 times negative 1/2 squared, I'm going to draw a little thing over there, plus 3 times negative 1/2 plus 1 equals 0. And then you just simplify that and make sure that you get 0 on this side. And just remember that a negative number squared, like negative 2 times negative 2, is positive 4. Okay, so that is the quadratic formula. Super, super useful. It will come up all the time, I promise you. But it's not very hard to wield, so it's a really good thing to get used to. The last thing I want to talk about is graphing, and I'm going to touch on this very briefly. And so in this case, when we're talking about roots, we're really talking about the point at which our graph crosses the x-axis, because that's when y on the horizontal or on the vertical axis, that's when y is 0. Let's look at a simple example like y equals x squared. So since this is a slightly higher level discussion, I'm not really going to draw a super accurate graph, but suffice to say it looks like this. And in this case, there's actually only one root because y equals 0 when x equals 0. Again, you can double check me on that. But we will have polynomials of all different types, and so you might have a graph that looks like that. And in this case, you're going to have two places at which y equals 0. And you'll see that even though y is 0 for both of these, x is different. Okay, so to do this, to graph it, you can either create a chart of values where you pick different numbers for x, plug them into your equation, and solve for y. So if x was 0, y was 0. In this simple example, if x was 1, 1 squared is just 1. If you did 2, 2 squared is 4, etc. If you did negative numbers, you would find the same, which is why it's mirrored across the y-axis. So that's how you would graph by hand. If you have some sort of graphing software, you can just plug in the equation and it'll plot it for you. And then you can either do it by hand, like zoom into the graph and look at the x-axis, or you can plug in when y is 0 and it'll the software will tell you what the values of x are. Super handy. Also probably why in your algebra classes your teachers will not let you use your graphing calculators on the test. Sorry. But in that case, just memorize the quadratic formula. You got it. All right, I will leave it there for now. Please let me know if you have any questions about polynomials, solving polynomials, simplifying them, any of the things that I've talked about in here, or if you have other algebra or other math topics that you would like to cover, and we can tackle them together. All right, thank you very much for watching, and we'll see you next time. Bye!